Alright, our next video, 10.2.8, our final two circle angle theorems. The first one, Theorem 3, angles at the circumference. Angles subtended by the same arc or chord. So you can see here there's an arc, or if I wanted to I could just as easily say that was subtended by the same chord, they're the same. My rule tells me that the angles at the circumference will be equal. How would I go about proving that? Well, if we take a point at the center of the circle, let's say that's the center of the circle there, then from our first angle theorem, we know that the angle at the center is double the angle at the circumference. So if that angle in the middle is 2 theta, then the one on the right must be theta. But I could use the same argument to say, well, if the angle at the center is 2 theta, then the angle on the left must be theta. So we end up with the angle at the circumference anywhere, wherever I draw it, is going to be theta. Even if I draw it right over here, still going to be theta. They'll all be equal. That's it. That's all there is to that one. Angles at the circumference subtended by the same arc in the same segment, so they're all on the same side of the chord or of the arc, are equal. Let's have a look at Theorem 4 about cyclic quadrilaterals. What is a cyclic quadrilateral? A cyclic quadrilateral is one where, you can see I've underlined it there already for you, it has all 4 vertices sitting on the same circle. If you have that situation, you have a cyclic quadrilateral. I'm going to draw in a cyclic quadrilateral here with my incredible artistic skills. Now, how am I going to go about proving that these opposite angles are supplementary? Well, let's put the center of the circle in and see what we can come up with. Here I've got A, B, C, and D. Might be easier if I label the angles like that, A degrees, B degrees. But either way of labeling them is fine, it doesn't really matter. Now what I'm going to do, I'm going to ignore B and D for the moment, and I'm going to show that A and C are supplementary. And the way I'm going to do that is I'm going to draw lines to the center of the circle from B and D. So there's my center or origin of the circle. Now, our very first rule again that we just used to prove Theorem 3, we're going to use to prove this one. Angles at the circumference are twice the angle, at the circumference are half the angle subtended at the center, or the angle at the center is double the angle at the edge. So here where I have angle C, that must see how that C is to the left of the point. So this point here must be 2C at the center. Again, that's to the left of the point. If you see from the arc DB, I've drawn the secants towards A. That angle A degrees there must be half of the angle at the center here, which is 2A. Now, we all know that in a full revolution, so in this case 2A plus 2C, we have 360 degrees. Well, a little bit of factorizing. 2 times A plus C must equal 360. That is going to let me scroll down, divide by 2, and I get A plus C equals 180 degrees. Now I could just as easily rub out those points, show that the angles B and D are half the angles at the center, and use the same argument to show that B and D are supplementary. So therefore, opposite angles in a cyclic quadrilateral are always supplementary. Let's have a look at some of what are supposedly the harder questions here and see how we go with those. You can see that really this exercise, although it's all 10A work, although it's a bit more challenging in theory, it's not essential for getting a C, we're still going to be able to do this quite easily. I'm going to give up on resizing those. You could see it wasn't working there. Let's have a look. Find the values of the pronumerals in these circles. Well, that angle there, A, is subtended from this arc. So the equivalent angle at the circumference is 30. So, very simply, A equals 30. Now I don't need to worry about the degrees because it was A degrees equals 30 degrees. So A is equal to the number 30. If you consider the arc at the top of the circle there, you can see I've highlighted it there, well then this angle here is opposite that one there. So this extra angle is going to be 50. How do I work out B? Well, B equals 180 minus the 50 minus 30, because they're the other two angles in the triangle. So B is going to equal 100 degrees. Not so bad. I'm just going to cut this out and see if I can move these last two a bit further down. Give us a bit more room for our working. Now it might even let me resize them. I wanted to. Yay. Alright, let's go ahead and see if we can have a go at B and then C. Alright, so 54 degrees down the bottom. If we use the highlighter, that's probably the easiest way to highlight. There's the arc. That's giving me 54 there. So we can tell from that that A must also be 54 degrees. If I went the other way, if we get rid of those, I'm not using that arc. Let's use the arc down the bottom here, or they've drawn a chord. Let's use the chord. Seems though they went to the trouble of drawing one in for us. That chord subtends an angle of 36 degrees at the circumference, and that must be the same wherever that chord subtends an angle at the circumference, so that's also going to be 36 degrees. So how am I going to get B? B plus 36 plus 54 equals 180. B equals 90 degrees. Pretty straightforward again. These are the problem solving ones. Who thought maths was going to be so easy? Alright, here, cyclic quadrilateral. Straight away I know A plus 75, they're supplementary. They're opposite angles in a cyclic quadrilateral. They're supplementary, so A is equal to 105 degrees. Oh, I didn't need the degree sign this time, but that's okay. No one's going to really mind either way. Now, we've got a pair of parallel lines there. You can see they've been highlighted there and there. What does that mean? That means that B and 75 are co-interior angles. What do we know about co-interior angles? Correct, they are supplementary. So B plus 75 equals 180. That's going to tell me that B equals 105 degrees. And since this is a cyclic quadrilateral, C plus B equals 180. C plus 105 equals 180. Put our degree symbols everywhere. Then C equals 75 degrees. And you got all your answers. Good luck with the questions. I don't think you'll find them too bad. Cheers.